Hello guys, so today I'm participating in this Codeforces contest, educational round 172. So let's see how it goes. Okay, let's start with C first. Okay, let's arrange this a bit. Okay, uh, so competitive fishing. Okay, Alison Bob participated in a fishing contest. In total, they caught N fishes numbered from 1 to N. Okay. Mm, okay, one. In total, they got N fish numbered from 1 to N. The bigger fish, the greater index. Okay, some of the fish were caught by Alice, others by Bob. Their performance will be evaluated as follows. Okay, first an integer M will be chosen, and all fish will be split into M non-empty groups. Okay, and all fish will be split into M non-empty groups. The first group should contain several smallest fishes. The second group several at least one. Okay, second group at least one. And several next smallest fishes and so on. Each fish should belong to exactly one group. Okay, and each group should be contiguous subsegment of fishes. Note that the group are numbered in exactly that order. Okay, for example, the fishes from the second group cannot be smaller than the fishes from the first group since the first group contains the smallest fishes. Something like increasing. Okay. Then each fish will be assigned a value according to its group index. Okay, something like this. Uh, Group index. Each fish in the first group will be, oh, okay, 0. Each fish in the second group, and so on. Okay. The score of each contestant is simply the total value of all fishes that contestant caught. Okay. Let's finish. Okay, the score of each contestant is simply the total value of all fishes that contestant caught. Okay, you want Bob's score to exceed Alice's score by at least K points. Okay, I do not want that. Question wants that. It should be at least K. Okay. What is the minimum number of groups you have to split the fishes into? If it is possible, you should report that. Okay, let's think about it. I have fishes. Then the next thing I want to do is have to assign them in a group. Okay. Okay, so difference. Okay, case like this. Oh, okay. What is this? Okay. This is a string consisting of n characters. The ith character is 0, denoting the ith fish caught by Alice, and 1, denoting the ith fish caught by fire. Additionally, considered on the input sum of this. You have to split the fishes or -1 if it is impossible. Okay. binary. Oh, they are number 1 to n. Bigger the fish, greater. Okay, greater the index. Okay. So how can I divide this? What can I do here is this test case 42010. Okay, 0 denoting Alice, 1 denoting Bob, right? 1, 2, 3, 4. Okay. So Alice, Bob, we have 1 and 4. This is 2 and 3. Okay. Then I have to decide the number of groups. If I sort them, this is already sorted. Oh, okay. This is already sorted. M non-empty groups. If M is 1, I do. What will happen? I have 1, 2, 3. This is one group. So both of them will get 0, 0. Now if I do at least K, right? So what should I do? So I should maximize Bob's score. How can I maximize? If Bob has anything in the largest group, okay. Bob has something in the largest group. Let's think. Something in the largest group. Then what will I do? I should maximize that, right? Hmm. I use some kind of first of all, if something is there. I do something kind of, so here I have this. What will it happen? So overall Bob is kind of collecting 5. This is also 5. How will I divide them in the group? I have this order, so I cannot change this. Okay. Now I do something kind of, this. These are scores, right? I mean, these are fishes caught by them. So if I look at this, mm, this will carry forward. So I can do easily. By this, I will get to know how many each of them is carrying. Or oh, okay. Or what can I do is I want Bob only, right? So instead of this is Alice. I don't want this. I want Bob, and then Alice. If I do a prefix, it will look something like, hey, something went down and Bob got. Okay, then I got this, then it went into 0. Okay, this was balanced. Okay, similarly, if I do think mm, some kind of this is incorrect. Yeah. Second used okay, I have an idea, but I think I have this. I need some kind of a mechanism that can tell me the segments, right? that can tell me segments. And I have to find the segments. I need some kind of a splitting. I know they are increasing order. I know which fish Bob has caught. Okay. I know which of them Bob caught. I know which of them this. I know they are increasing. Fish is increasing. Bob and this is this. Now simply need to check there. One of them has Bob caught. Bob score will be 0 here, right? Score Bob blockwise. That's their score. I have solved something like this. Alice one I do not want. That will decrease my score. Right? Yes. So yes. Bob Alice should be greater than K. What does it mean? I have to increase this. I have to decrease this. Right? And that's why this will increase. So contribution wise, if I look, let's say 0 1 1 0. Okay, K is 4 test case. Check a value. K is 1. Okay, here 1 1 1 and minus 1. Yes, this is this. Now if I compute the prefix with this 3 minus 1 0 1, this will be 0. Now what does this mean? Now once I have this, I can easily so this part, okay, this should be something like this. I'm doing, and that is bad because I'll be assigning 2 here, I'll be assigning 1 here, and I'll be assigning 0 here. The first fish in the first group, the last 3 fish in the second group. Yes. Yeah, so 2. So Bob's score will be 4, Ali's score will be 2 plus 3. Yeah, okay. This part, right? higher the fish, yeah, higher than the higher the fish. But this is I do. Okay, the second say this is my contribution, right? The fish. Hmm. Uh, this part I know, this part I know, this part I know. Can I apply some kind of a binary search? Hmm. Should be easy. This should be easy. Okay, so then clicking. Okay. Then the string. Okay, this CNS. Okay, now I can I'm saying about contribution to the score. Okay, then this will be for each position I will be doing this. So n then for contribution is this is -1 if s of if I equal to 0, then this is a -1, otherwise this is 1. Okay. Hmm. So this is how it will look. Now, what can I do is I can create the contributions, right? Okay. I have this, because as I go on decreasing, this will tell me uh, how to divide it. Yeah, this will tell me how to divide it. -1 here means uh, -1 here means I like this part is bad, so putting this part in the upper as a separate segment is bad. Okay, now this segment will be 0. Okay, that is something related to contribution, right? Maybe put it like this. Okay. Dun, 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 dun. Dun, 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 dun. If I consider this part, this is -1. If I consider this part, oh yeah, if I consider this part, if I consider this part, yes. If I consider this part, if I consider this part. So I'm getting 1 here, which means I'll get a big score here, right? Because Bob's score is 1 here. So I should divide it here, right? should divide it at least here. This I don't care. Now if this is the biggest part from Bob, okay, this part, like this group holds the biggest contributions for Bob, then yeah, then once I have this mm, then I have to compute for other segments also, right? Then I have to compute for other segments also. Yes, yes. Hmm. It was this one, this segment I don't need to consider. Okay, this is the biggest. Square will increase. Zero here and zero. This segments. Now once I have this segments, uh, once I have this segments, so if I have this, okay. Hmm. Easy, easy, easy. This is solvable. This is solvable. This is solvable. Need to figure out how to calculate this score, right? Ah, the calculation of scores. I know which segments I should choose, right? I know which segment should I choose. Now, this basically tell me what are the contributions in the segment. I will take the biggest contribution or the biggest segment score. Okay. And I run a prefix. Yep. Let's run it. And I have to say whenever I got a prefix, okay, here I'm getting 1 greater than k, and this is prefix of the segment. Okay. The suffix sum. Now suffix sum will start from the end, right? So suffix of I is equal to its contribution of j. No. I'll start from end. This will be there, and this should be, yeah, the end will tell me yes. This should start from -1, and this will automatically take care of that. Cool. And this should be suffix of I plus 1. Yep. Cool. Cool. I got this 1011. Cool. Now here I have to take this, right? The sum basically. Yep. Okay. So in segment values. This. As as of suffix of someone is calling. And this will contain these bits of that. Okay. Yep. Now I know which part. Okay. Then I have got the segments. Yes. Now they are in descending order. Now I can easily compute the prefixes. Okay, so do prefix and this will be the values. There's a variable here. Let's consider this will be m. And this will be n. Okay, now set values. This seg values. Okay. Then I got this. Then so will be possible groupings. I two and so this will tell me the groupings for it, right? Yeah, so this will tell me groupings for it. Now here I can simply check if they should be non-empty. Okay, if prefix of -1 greater than k, then I can set to I and it's not equal to and it's not. Oh, okay, everything is matching. Okay, this is done. I hope so. Whew. Okay, cool. Fuck, I'm so nervous. I am so nervous. Okay. Recommendation. So let's sort this. Are there any scorings? Not yet. Okay. Check out standings. Okay, let's quickly solve A and B then. Okay, there are ranches. The IA chest initially contains AI coin. For each chest, you can choose a non-negative integer. Negative coins to add the chest with one constraint. Coins in the chest must become at least k. Fuck you, Microsoft. I literally have an iPad, but I cannot connect in this fucking Windows laptop. Yeah. Mm-hmm. After I finish adding a greedy monocop comes who wants the coin, he will take the chest one by one. And since he is greedy, he will always choose the chest with the maximum number of coins. Monocop will stop as soon as the total number of coins in chest he takes is at least K. Okay. You want Monocop to take as few coins as possible, so you have to add coins to the chest in such a way that when Monocop stop taking chests, he will have exactly K coins. Calculate the minimum number of coins you need to add. You have to add. I understand this part. Yeah, I was just thinking like, should I give time to A or B? But this looks easy. Shouldn't be issue. Okay, so for each chest, you can choose a non-negative integer, right? Non-negative number of coins to add to that chest. Yep, with one considered that total number of coins in all chest must become at least K. So summation of AI. Which chest? For each chest, you can choose any non-negative number of coins to add to that chest. Oh, okay. Initially, we have something like this, and I can choose any non-negative number of coins, and I can add in that chest. With one, consider that the total number of coins in all chests must become at least K. Okay. Okay. Then after I have finished adding coins to the chest, greedy monograph will come. Okay, who wants the coin? He will take the chest one by one, and since he is greedy, he will always choose the max chest with the maximum number of coins. Okay, monograph will choose as soon as the total number of coins in chest he takes is at least K. Okay, okay, okay. Makes sense. You want monocop to take as few coins as possible. As few coins as possible, so you have to add coins to the chests in such a way that when monocop stop taking chests, he will exactly, he will have exactly k coins. K coins. Calculate the minimum number of coins you have to add. I have 4. I mean, I have 1, 2, 3, 4. And here k is 4. I don't need to add this, he can directly take this. 1, 2, 2, 3, 4. I have 10. Okay. The fourth chest. Hmm. I have to make sure he will take exactly k coins. So if you take this, okay, so 10 minutes, I will be narrowed down to 6. If it takes 3, okay, I'll be narrowed down to 3. I mean, on 2, I can add 1, I can make it 3. I mean, I have to add minimum coins. It's again some kind of stuff. I have to make sure he takes exactly k coins with him, right? Yes. Hmm. Yes. First, let's sort this. Okay. So if I start from the end, okay. So for this guy, the goal will be adding 6 coins directly, right? 4, 3, 2, 2, 1. When I have k equal to 10, if I only consider this, and then for this guy, this will be like 6 coin. Now I have this. I have 7 coins. Now I have this. I have 9 coins. Now I have this. This will exceed. Okay. So to that index, right? What about this? Oh, it will be less than equal to k. Okay, s will become v of I. Okay, now if s is greater than k, idx will be this. Okay, idx will be idx plus 1. Okay, okay, fuck. Why is it? Ah, okay, cool. Double sure. I don't need index also. Loading every time. Okay, this is kind of a symphony in Codeforces. Wrong answer at test case 2. It's kind of very common in Codeforces. Did I get something like that? Oh, okay, cool. I got accepted. Nice. Okay. I was a little scared, like it will give me wrong answer. So I got this and this. Let's look at the standing. Okay, 7k. Is C is solved a many person? Okay, I have to solve B. Okay. Alice and Bob play a game. There are n marbles of. Why is it so big question? Why? Alice and Bob play a game. There are n marbles. The ith of them has a color C of I. N marble color C of I. The players take turn. Alice goes first, then Bob, then Alice again, and Bob again, and so on. During the play, a player must take one of the remaining marbles and remove it from the game. If there are no marbles left, the game ends. All marbles have been taken. During that, a player must take one of the remaining marbles and remove it from the game. Okay. Alice score at the end is calculated as follows. She receives 1 point for every color X such that she has taken at least one marble of that color. She has taken at least one marble of that color. Additionally, she receives 1 point for every color X such that she has taken all marbles of that color. Okay, so for example, let's say we have RGB. First of all, for each marble take, I get a color, like I get 1 point. Now if I have taken all red marbles, I get, like, Alice get 1 more point. Okay, for example, there are 5 marbles, their colors are 1, 2, 3. The game goes as follows: Alice takes first marble, then Bob takes the third marble. Why Bob takes the third marble? Why? Then Alice takes the fifth marble, which is 4. Then Bob takes the second marble, and finally Alice takes the fourth marble. Okay, then Alice receives points for 4.3 for at least 1 marble for color 134, and 1 point for having all marbles of color 4. Not necessarily optimal marble. Okay, Alice wants to maximize her score at the end of the game. Bob wants to minimize it. Both players play optimally. Okay. To maximize her score at the end of the game, Bob wants to minimize it. Why, Bob? Why you are so cruel? Get a girl. Both players play optimally. Alice chooses a strategy which allows her to get as many points as possible, and Bob chooses a strategy which minimizes the amount of points Alice can get. Why Bob is so mischievous? Uh, okay, so what we can do is, so what should be the aim for Alice? Should be the aim for Alice? Alice Alice should try to get all the marbles of the same color first. Now Bob knows that, so he will not let that happen. He will choose a different color, right? Yeah. If Alice chooses this and this, okay, I have two, and I have one. Okay. What should whichever one is single, Alice should take that first, right? Yes. So because one marble has a frequency of 1, Alice should choose those first. Yep, because she will get 2 points for them. Yep. Then then the number of marble that we have. Okay, so if I have n marble, and out of them, let's say I have some C, this. Okay, so I should take this. So she will have 2. Then here they can either choose one of them. Then here they can choose either one of them. So 1 here, 1 here. Then Bob doesn't have, yeah, Bob doesn't have any score. It's only Alice. Yeah. Okay. Scores are varying between levels. Okay, so finders are can do something like that. Then end SG this one. Okay, for int I equal to, I have color 1. Oh, first I have to take the input. Fuck. Okay. Anyways, I have this. Can take this V and then C map VI. Okay. Now I have taken this input. Then I will do the thing. I will count the frequency under of V of I plus plus. Now count will be the number of yeah, so this will be as a count of 1. Cool. Now once I have this, then the total number of coins, unique coins I have. Yes, so oh, that also I have to do something like that. So yeah, that I can figure out. All that will be SG minus all coins having 0. Unique coin is J SG minus count of finder and of 0. This will give me all the unique coins, and yeah, then my answer will be all the single coins that I have. Yep. So first of all the coins that I have. Okay. Alice will take at least one of them. Right. So Bob should first eliminate all of those coins, right? Which are more than 1. Now Alice should pick them up first. Okay. So this will be the unique coins I have plus I got this. Yeah, the answer is they should take all the unique coins that I have, then the number of coins which zero frequency. I just thought of something. This I have C, then I know U, which is my unique count, number of coins. Now out of that, if I eliminate all the numbers which are this, then $1,000, right? Then Alice, this is 1. Bob will take 1 from this. I'll just do 2 points, right? And just get 2 points for each completion. So count. Now if it is odd, this by 2, okay, then I'll do count, okay. Is it correct? Okay, no. Oh, work. Date bhaiyo. Run. Yes, 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 sir. Cool. Please, something good happen. Please, something good happen. Woo! Cool. Nice motivation. Okay, this is done. Now problem D, my nemesis. D now. Okay. Yes. Okay, looks interesting. Suppose you are working in some audio streaming service. Why? I will not suppose that. Okay, the service has inactive users and 10 to the power 9 tracks user can listen to. Spotify? Okay. Users can like tracks and based on likes the service should recommend them new tracks. Okay. Some kind of a machine learning. Okay. Tracks number 1. This it turns out that tracks the ith user likes from a segment li ri tracks the ith user likes from segment this. Let's say it turns out that tracks that ith user likes form a segment L of I to Ri. Okay, who discovered that? Okay, then let's say that the user J is a predictor for user I. If user J likes all tracks the ith user likes, okay, it's a predictor for I. Okay, if two people are listening to the same track, then okay, then it makes sense. Both of them have the same taste. Okay, and also let's say that a track is strongly recommended for user I if track is not liked by the ith user yet, but it is liked by every predictor of ith user. Okay. 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 Calculate the number of strongly recommended tracks for each user I. If a user does not have any predictors, then print 0 for that user. First, it looks like a graph. I have to say that. Okay, so we have some predictor, right? How will I figure out the predictor? Number of user, LIRI per line, the segment of the track, the ith user. The first user like 3 to 8. Okay, let's do it in another line. Yep. So I have 2, 3, 4, 5, and 8. So I have one user which is in this segment. I have another user which is in this segment, and I have another this. So 3 and 8 is a predictor for this user. Okay. Also, so let's say this is 3, this is first, this is 2. So for 3, these 2 are predictors. Okay. Let's say that this track is strongly recommended for the ith user. The ith user. Just a second. Should not try this, but let's see. Sometimes these are easier than D. Hmm. One px, a of px, two of px. Okay. And third is find two non-empty non-overlapping subarrays. Non-empty and non-overlapping subarrays within the segment L and R with the maximum total cost and print their cost. How can I find this? Fuck it. Fuck it. Fuck it. Fuck it. Fuck it. Yeah, less time. Prefix, right? Prefix, not prefix. Prefix. No, 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 not prefix. It's predictor of JS likes tracks I strongly recommended. The track is not liked by the user, but it is liked by every user. Every predictor. Oh, so here three. Okay, calculate the number of recommended tracks for each user I. If a user does not have a predictor, to print 0. The ith user. If I have this graph, then I will know which one is whose predictor. 10 to the power 5, right? Okay. Okay, segments. I'm finding parent for them. Segment based parenting. I need to smoke. People have solved this. Okay, numbers are increasing. Jiangli has solved this. Okay. Jiangli must have finished it. Okay. He got one wrong attempt in ENF. Why these people are so fucking fast? Let's say that a track is strongly recommended for this. Every predictor. Okay, so for 3, N is in between this. Li and Ri is this. Okay, I cannot build contribution kind of thing. Cannot build contribution kind of thing. What should I do to find it? This tends to be 9, right? Okay, benefit of a map. It's segmentary. I have zero fucking idea. If I find the max segment user, max segment user means it has its kind of root, OG. Okay, let's look at here. 3, 8. So this contains, there is also 6 here, right? There is also 6 here. This is not recommended by all the. This is not recommended by any of the ancestor, any of the predictor. Yep. This is clearly overlapping this. If I short them with respect to their segment length. Here, This user is liking all the track. This guy. Okay, what about this case? Third. Okay, these two are same. Okay. Okay, so if I have segments that are completely overlapping. Hmm. Then the segment. Then the segment. Then the segment. Within the segment. Hmm. upper bound kind of here. Limit here. What is the lower bound of this? None. What's the upper bound of this? This. Then from here, what is the upper bound? No, this is kind of the. Okay, if I have some kind of this here. If I'm at here, what's the upper bound of this? What's the upper bound of this? What will happen in lower bound? I have think, bro. Think. Segments. I have segments. Now within the segments. Mm-hmm. Mm-hmm. 10. I got 3. I have 4. And there is a 2. There is a 5. And there is a 7. Okay, so I have one segment here. Okay, then 4. I have 1, 4 to 4. 5, 7. Right now, all of them are different. Okay. Then I got a big segment 3 7 3 7. So for every input, do I need to calculate the ancestor? Okay. Then 3 10. Then in the end 1 10. Two and three have kind of a common ancestor. Just 4. 4 as the ancestor. Predator, which is 5. I need to make this connection. If this is the ancestor of this is the ancestor of this, so 5 becomes automatically a predictor for this and this. Then I have 6. If something is here, that has to be here. Now if something is here, that has to be here. Okay. Repair tracks. If I put them like this, go hide. The child. This one. So here's hey, what to be. So if the first part is same for both of them, then consider this one for shorting, otherwise a dot first b less than b dot second. Wait, automatic does that, right? Okay, so I am saying 1 and 10. So get all the predators for this. Okay, predictors for this. No, who will be predictor for this? None, right? Because this is the biggest segment. Okay, so uh, now the find predictor thing. How can I find the predictor? 5, 7. So I have 5 and 7. If I ask find the predictor of this, okay, so I should try to find the next bigger segment which include this one. Okay, the next bigger segment which include this one, which is 4. How will I find the next bigger segment which include this? Uh, if I set of pairs, is it possible? Okay, set of pairs is there. Okay, so we'll do insert A, B. Okay, now this will help me to find this thing. Okay, let's say I have some hypothetical function to find the predictor. Then what to do? If I know the predictor of this segment, if I know the predictor of this segment, okay, then 5 and 7. 3. There is a 6, 8, 9. Okay. This also cuts. Okay, so the first parent itself. Okay. That's why it is 4. First parent is this. This is the first parent. 5, 7. That's why 2. I. Then this I have now to define this f somehow. Should take the track, right? How can I now find the first parent? And before that, I need some pre-processing. But how can I find the first parent? I have this segment. I was thinking of some kind of a shorting will help. Fuck this. I will not see. I will not see. Fuck it. So for this. Uh, but this, I don't need this. I want this. Compute the overlapping area. Okay, this also has to change. Uh, okay. Hmm. I'm not able to think. Yeah, this will probably increase. Cool. I have right. Hmm. Need to work on more. Hmm. Fuck, 1,000 people. This must be some. Okay. Hey, the contest is over, right? What the fuck? The contest is over. They're like, this is like basketball. Like the time is up, but the player just threw the ball and the ball just like drop in the net. Even if the time is ball, like the time is up, the ball just drop, right? So it's a basket. So yeah. Okay, cool. It's done. Uh, let's see. Uh, increased. So let's look at where is that? Where's the common standing? Yeah. Who are these people? Or should I say more precisely, who are these smart peeps? I really like Jiangli's coding style. It's pretty clean and good for reference. Ah, okay, he was using some kind of a binary search. Kuso. Not able to solve. I was thinking of some. Okay, this is something different. I didn't think of it. But I was thinking of building some kind of a array that will store the left and the right parts and I can individually sort them. But I guess he has done something different. Let's put this inside a closer. Not sure why. What's this? Got this and this. Then you created a P. Okay. What is this P used for? Anywhere here P getting used? Nope. Okay. Hmm. Mm, what the fuck? So, uh, he's saying I already have the shorted array. Phi if not equal to all of j, then return. Okay, otherwise return this. Okay, this is for shorting. Then I actually don't know about this algorithm. I have to see. But yeah, so yeah, this is how it goes. So this was my screencast for Codeforces Education Round 172. I still yet to improve a lot. Like up to C, the problems were pretty like standard. Not much algorithms or data structures were used. Just maths. But yeah, D, E, and F. Yeah, this is something I have to work. So yeah, I hope you guys learned something new in this video, and I hope you guys enjoyed my struggling. So yeah, just stay tuned to watch more videos on it. I will be uploading more screencast on contest on AdCoder and Codeforces. So yeah, feel free to watch them. Thanks for watching.